Alright, congratulations on finishing the do now. Now we have two objectives that we need to learn today. First, we need to be able to perform what's called function combinations. So I'm going to title the left-hand side of my paper, Function Combinations. Now function combinations are exactly how they sound. We're going to combine functions. And we can combine functions by adding, subtracting, multiplying, and dividing functions. So let's see what that looks like. Alright, so example number one. Say we have two functions. We have the function f, and it is going to be equal to 3 times the quantity x minus 2 to the 1/2 power. And then we also have the function g. So g of x is equal to 5 times the quantity x minus 2 to the 1/2 power. And the directions may say find f of x minus g of x. So f of x minus g of x means we're simply subtracting our two functions. Well, f of x is 3 times x minus 2 to the 1/2. G of x is 5 times x minus 2 to the 1/2. So we subtract the two. Okay, now we just remember from last class that I can subtract and add like radicals. We must remember that rational exponents, so an exponent that's a fraction, can be converted to a radical. So I'm going to do that. So something to the 1/2 power is the same thing as the square root . And now I see, yep, these are like radicals. They have the same index of 2. Right? If we don't see a number here, we know that it's a 2, it's a square root. And they have the same radicand of x minus 2, x minus 2. So I can combine these two. 3 minus 5 is negative 2. So this is f of x minus g of x. Now something else you're going to be asked to do is state the domain of this function. So the directions would be find f of x minus g of x, then state the domain. Now remember from your video that you watched last night, the domain are all of the x values that return a defined value. So in a function, almost every single input is going to output a defined value, except for two cases. The first case is you will have an undefined output if you take the square root of a negative. Right? We can't take the square root of a negative. It returns an undefined answer. So if x minus 2 is ever negative, it will return an undefined answer. So x minus 2 has to be positive. Right? It has to be greater than or equal to 0, meaning x has to be greater than or equal to 2. So our domain are all of the x values, all of the inputs that are 2 or greater. And that ought to make sense. Let's try a number less than 2, like 1. If I plug in 1 in for here, 1 minus 2 is negative 1. The square root of negative 1 is undefined. Whereas if we pick a number bigger than 2, like 3, 3 minus 2 is 1. Yeah, we can take the square root of 1. That's defined. So in this case, our domain is x is greater than or equal to 2. Let's do another example. Number 2. Once again, I have two functions. F of x equals 2x minus 5, and g of x equals x squared minus x minus 6. And the directions are find f of x divided by g of x, then state the domain. Okay, so f of x divided by g of x is f of x, which is 2x minus 5, over g of x, which is x squared minus x minus 6. That's it. That's f of x divided by g of x. I would simplify this if I could, meaning if there was a common factor between the numerator and denominator, I would factor it out and cancel. But there isn't. So that's f of x divided by g of x. Now let's find the domain. Now we noticed in the last problem, one way that we might get it, that we would get an undefined answer is if we take the square root of a negative. The second way you must remember for there to be an undefined answer is if you ever divide by 0, right? Division by 0 is undefined. So we can plug in any x value we want here, except if the denominator is equal to 0. So the denominator is not allowed to be 0. X squared minus x minus 6 cannot be 0. So I need to solve and see, okay, what x values would cause the denominator to be 0? Well, I notice here that this is a quadratic, and I can solve quadratics using multiple different methods. I can complete the square, I can use the quadratic formula, I could factor, and I look at this and see, oh, I can factor this. There's two numbers that multiply to get negative 6, but add to get negative 1. Right? Negative 3 and positive 2 multiply to get negative 6 and add to get negative 1. So if I, by the zero product property, I see that x cannot be 3 and x cannot be negative 2. Any other x values are fine except for these two. These two, if I plug them in for x, and you could pause this video and try, you'll see that it would cause the denominator to be 0, which would return an undefined solution. So our domain is x cannot be 3, x cannot be negative 2, x can be any other value except those two.